Now we have successfully entered the site-specific information. Select the PV modules for the projects and the preferred TRT racking system and components. Enter the general building information and perform the desired span check. Then we're ready to move to the fun part of this tool, laying out the PA modules. Currently, this tool provides 4 layout tabs, allowing you to design 4 specific PV module areas for your project. The layout sheet provides you 5 design tools, 2 graphical displays, and 1 dynamic BOM display for this particular area. The roof dimension tool table gives you the capability to define the layout area dimension and shape. The module placement tool table gives you a fine granularity of designing placement of the solar panel. Rectangular and circular keep out tool give you the capability to avoid objects on the roof. And the array gap tool table give you the capability to add abnormal vertical or horizontal gaps between the row or column of the solar panel. The display graph at the bottom is actually the help for this page. It defines all the terms used in the table tool and the color coded, meaning of the color code. There are not many predefined input on this tab. Most of them are trial and success type of design input. Just pay attention to these 2 fields. First of all, you can select the orientation of your solar panel, either landscape or portrait. By default, the tool will automatically fill the area with as much panel as possible. There's a max number of modules. It's default at 100. If you know your number of modules in this area, you can change the number so you reduce the number of trials you have. Let's use the example project to demonstrate how to use those table tools. Okay, for this particular project, we're going to design 2 PV module areas. We're going to use the layout 1 to design the first area. The dimension is about 33 feet by 15 feet. In the roof dimension table, you basically define the origin and the size of the area you're going to work with. So let's just looked up. It was 33 by 15. You use the ridge offset to change the shape of the roof. Yeah, basically it gives you the flexibility to change the shape of the roof. Then we're going to use the module placement table tool to fine-tune the placement of solar module. you want to always give some buffer from the area edge to be at least feet. Yeah, remember all those numbers on this page. The unit is feet. Feet. Let's give it all half feet. Horizontal. Yeah, those module horizontal and module vertical gap. You see those decimal numbers. Normally you don't want to touch this. This basically the spacing between panels and matching our middle clips. So there's no particular reason you want to keep it as they are. Also, the module real overhang basically give you some little bit extra at the very edge of the solar modules. So there's some space you can work with. If you have sufficient space for the area you want to put the number panel in, you always like to push the panel into the zone 1 and keep it as a rectangular shape. There's many ways you can do that with the tool, so I can just demonstrate a few. In order to make the panel like 2 by 6, let's place some numbers here. So from the hip buffer, we want to increase it to 3. So it push it to the right. And still not 2 by 6. Let's play with some offsets. Let's increase the horizontal offset. Now you're achieving the 2 by 6, and if you want to move everything into the zone 1, you can reduce this one to 0. Yeah, so that's basically place the 12 panels for this area in the zone 1 and with the rectangular shape. Yeah, I would like to point out the span check status actually displayed here on every layout pages. Next, I'm going to use this layout 1 tab to demonstrate the a recap tool. So if for some reason you want a wider gap between panels other than the defined middle clamp spacing, you can use this table tool to add vertical or horizontal gap. Specify the orientation and the column location. Second column and third column, you want to add 1 feet gap. Enter. Yeah, sometimes the tool do some calculation and the execution is in the queue. You want to maybe try one more time. Yeah. So you actually add 1 feet gap between the second and third column. And then you can add horizontal as well. So there's, since there are only 2 rows, you want to add between the rows. And maybe 0.5 feet. Yeah, I mentioned sometimes just take two entries to execute. Next, we're going to design the area 2 layout and demonstrate additional features of the design 2. We use layout number 2 tab, and we go back and look at the actual picture of the roof. So the second area is about 25 feet by 17 feet. So we start at 0, 0 as an origin, and we have 25, 17, and 25. And we actually have a 2x5 using one panel. So even though the maximum number is 100, the tool will automatically fill in the area defined. So we're pretty close to the final design we would like, and we can do a little adjustment. We'll tweak the horizontal offset a little bit. We try 1. Yep, it's close enough, and we are moving all the panels into the zone 1, and it's in the 2x5 format. Yeah, looking at the roof picture again, actually there's a vent right in the middle of the section. So we can use other design tools to avoid those areas. We have a rectangular keep out tool and a circular keep out tool. So we'll try the circular keep out tool first. Basically the X going to be between 10 and 15. So let's try 12.5. The Y section is actually around 11. And VDS, let's put 2 feet. Oh, it's a little bit too wide, so maybe just 1 feet. Yeah, with the circular keep out tool, you basically achieve the goal of avoiding the vent pipe on the roof. So they gave you a 4 and 5, total 9 panel design. Delete the circular keep out. We can actually use a rectangle just for a demonstration purpose. So it's going to be from 11.5. Y is use 11 again. And you want to put 3 feet. That's 4 feet. Yeah, it's a bit overkill, so actually let's make it lower to 9. And let's make it narrower. Yeah, so you can achieve the same goal to avoid the area by using the rectangular keep out tool. Now you pretty much finished your layout design for this project. And actually you can go to each layout area to check the individual area BOM for accuracy. And in the last tab here, you will have a summary of the project, give you a total count of the build material.